All right, hello everyone. Welcome to another edition of the HEIR monthly meeting. I'll jump right into it and start going through the stuff that's changed since last time. So we had 55 PRs merged. Some of the highlights, we have an initial SBox implementation in MLIR that is part of AES transciphering that's used to test our CGGI pipeline. We have this new rotate and reduce op. And so the HEIR optimization pipeline has been migrated to use that new lowering path, which does like baby step, giant step, and some other fancy stuff. We have a new layout folding analysis that we use in our layout optimization pipeline that can basically look at a layout conversion op and determine if it's effectively free, because it will be folded or hoisted up through the HEIR until it gets to the input. Or constant. We have some more progress on lowering the key switching operation from CKKS. We were able to remove the MLIR runner dependency in favor of doing everything by lowering to LLVM now. So that improves our build times a little bit. In the Python front end, we now support, you can use the same function name in multiple tests in the same module. So the generated test names are uniquified so that there's no conflict with the module. Okay, so a random GitHub workflow thing. So all of our GitHub workflows now install the LLVM toolchain directly from llvm.org. So rather than relying on whatever the operating system package manager happens to have available in it, this means that our LLVM or our Clang test matrix is more robust and goes up to Clang 21, I think. We have so we have our Halevi-Shoup matrix vector kernel using the arithmetic DAG framework now. I think all of our kernels now use the arithmetic DAG framework, but this is a nice framework that lets us basically unit test the individual kernel at the same time, in the same code that is able to lower it to IR. So you write against the C++ interface, and then there's two different code paths that will take that object that's generated and either run it on real data or lower it to IR. So this is a nice thing for people who are sick of dealing with MLIR stuff. So we have, so now we have a pass where if you inline function call, it will keep the attributes on the function call op propagated to the inlined op. And that is useful for polynomial approximation, because we had some of our ML front ends would represent a ReLU op as a function call, and we needed to say, oh, this ReLU op needs to be approximated to this degree with this domain, and that was being lost when we inlined the ReLU op. We are starting to add support for doing server-side pre-processing of plain texts and clear texts. So basically this means pre-packing plain texts that are server-side static constants. We're not quite done with all of the work here, but the couple steps are to separate the main function into a function that does the pre-processing, and then a sub-function that takes as input all the pre-processed data and then runs the rest of the function. And we're doing this for backwards compatibility, so you can still call the original function signature without doing any pre-processing, and it will still run the function as normal. But if you have pre-processed inputs, and then the second step is to generate helper functions that do the pre-processing and give you back the stuff that you need to call the function that takes the extra pre-processed function arguments. The steps that are not done are deciding what to include in the pre-processing. You can imagine that if you include every single materialized constant in pre-processing, that you'd get a huge list of function arguments. So there needs to be some smarts there. And I think the overall pipeline integration is not done. The Python front end doesn't take advantage of this yet. So I think there's some more work to do there. Yes. Okay. So the polynomial approximation now properly emits a Chebyshev polynomial from its approximation routine, so that we can have like end-to-end approximation and lowering in the Chebyshev basis. So that's done. Um, so in the new layout system, we added support for scalar layouts. We added support for tensor insert and tensor extract kernels. These are like the dumb thing where you just mask a particular index and then rotate it to the 0 slot. We had support for vector matrix multiplication and matrix multiplication in the layout propagation pass. This was me fixing a bug in the key switch thing where I was just not doing the right, thing. Okay, this one's a pretty big one. Now we have like the ability to run not directly through the Python front end. Sorry, not directly through the Python front end, but through Bazel. You can basically set up a Python test that will compile HEIR, get generated Python bindings, and then using some Python dependencies, set up the data and call the HEIR compiled function. And we wanted to do that because we have a Torch front end now, and we wanted to use the Torch helpers to load the data that we could then pass to HEIR. And doing that in C++ with the Torch API was just annoying. And so it was easier to just set up the Python. So now at this point, if you look at this PR, you should see an end-to-end test of a compiled MNIST Torch model with like data loaded through Torch, run through like our preprocessing helper or our client encryption helpers, and then MNIST inference, and then the result is encrypted and checked. So that's pretty cool. In a similar vein, we finally removed TOSA, all mentions of TOSA from the code base. Now we're focusing on, well, it's not clear what we're focusing on, either stable HLO or just ensuring that the tools that we have go straight to the knowledge. Okay, one of the last remaining steps of getting a new layout system in is the layout conversion algorithm. That was this paper of Voss, and Erkin, where it was doing like graph coloring to figure out how to turn like a repacking operation into like a shift network. So that one, I needed to generalize it to support our new layout system, and that's done. And then also has been working on 2D convolution support. So we have, right now we have the Orion convolution kernel that's in, and it's working. And the last thing that we have to do is canonicalize input IR to be in the right kind of convolution that we can use the kernel. So that one's nice. There are a couple of small front-end updates, simplification of dependencies, and update to number 0.62 for build issues. We have, yes, I think there's proper float comparison support now. And then we have this new like kernel testing framework. So if you have like a layout and you'd like to test it by actually materializing that layout on regular data and to put it like to pack it basically in a unit test, there's ways to do that, and then you can also apply the kernel directly to that. So you can do like the whole end-to-end packing and kernel testing pipeline in like a unit test on synthetic data. Okay, in progress PRs. So yeah, okay. So there's some dumb stuff. We have some. I tried to do like a Python release of the Python front end, and it didn't work because because OpenMP is not supported in the build system that we're using. We're using something called CI build build, which takes advantage of a Python standard called Mini Linux. If you haven't heard of this, this is like you build on this Mini Linux platform. It has very restricted dependencies, and then you can run it on lots and lots and lots of different Linux platforms. So for like a pure Python wheel, this is like a great option. You can do it with C++ compiled wheels, but it limits you to like, there's like a allow list of like 10 packages you're allowed to link against, and OpenMP is not one of them. So I'm not sure what to do here. You can read through that issue if you want to dip your toes in there. I was looking around at what other projects do. I think they just kind of don't use the framework, and they just have a bunch of different build workflows on different platforms. And I don't know how they test it. So, okay, open for advice and contributions if someone's feeling that they want to get dirty. Uh, okay, so we have. I wanted to add a fuzz testing framework. This was part of the shift network thing. My Python implementation of that of that layout conversion algorithm heavily used randomized testing and hypothesis testing, and I wanted to like keep that in C++. I didn't finish it, but I will do that soon. My main thing is I'm working on removing the old layout system. So there's a lot more work here than I anticipated because most of the secret to scheme conversions don't support multi-path ciphertexts, or they have like weird hacks around it. And so I'm removing all of those hacks and making the secret to scheme natively support multi-path ciphertexts. And it's a big PR, but it's mostly deleting code. So I'm also, there's an upstream change that is going to break our like context-aware dialects conversion fork. Um, I am in contact with the author, so I don't think it'll get merged before we come up with a solution. But like the upstream step is still not quite context aware enough for us to use it as is. So I'm trying to look for some workarounds so that we can at least not get broken by upstream changes. There was we had a new contributor who fixed some macOS API problems with our plaintext tests. The only problem is that the internal Google tooling thinks it's leaking memory. And I'm not sure if it's actually leaking memory or if it's one of those things where if you have extern C function defined in LLVM that like the tools just like can't figure out that it's actually properly managing its own memory. So I have to figure out what to do there. But in the future, if you want to check, you can actually run with this dash dash config equals address sanitizer or msanit or memory sanitizer, and it will do memory checks on the code as well. This is very helpful when working with ISL because ISL makes you manage all your own memory. Okay, there's another new, the same new contributor added support in the new layout conversion system for trying like random orderings of the shifts. This was a feature of the original paper that I didn't implement. And then I found some test cases we had where like it really needed to be implemented or else it would just really pick a bad, it would produce a bad shift network, like using 20 rotations when you only need one. So that's there. Yeah, I think we just need to review that and get it in. And then we have some work removing memrep from the C2GI pipeline and replacing it all with tensor semantic operations, which would be nice. And then we have, I think, as I mentioned, there's canonicalizations to clear for conf to the ops. And this, I think we tried doing this through the like stable HLO path, like torch to stable HLO to MLAR. And there's a different project called Torch MLIR, which seems to be a lot better for this. And so these are things basically to prepare for us to use Torch MLIR directly. Okay, notable new issues. We had some macOS build issues. I think we still have some macOS build issues. So my understanding of the situation is once this plain text tests are fixed, then the CI for macOS will work. That is kind of and like my Mac will build it. Beyond that, it's hard for me to diagnose everybody's issues. This was a new contributor who just went back and forth with us and couldn't get it to build, and I still can't figure out what is causing the problem. We did learn, however, that it's best if you don't use LLD. If you have brew install LLD, it will potentially cause issues. And so now the Bazel config should force just regular LD, but okay, your knowledge may vary. And then there's a new error with the read line. Are you hitting this one too, Mark? Okay, you're hitting this one too. So there was these are Yoast dependencies that are all like weird, obscure old C projects, and the configuration is just not set up properly. I had to update because one of the dependencies wasn't read line, it was a end curses, I think. They just like dropped support for actually fetching the code. Like the links were all dead, and so they added a new link that was not dead, and I had to update to allow us to build anything. But yeah, so I think if you hit this, run with disable Yosis, and it should try to load that, or should try to build it at least. Sorry, guys. I really want Mac OS builds to work, but everything is hard. Okay, there was a new paper about using larger lookup tables in CPKS. This one seems cool. I think they do up 16-bit LUTs in CPKS, and it's implemented on top of OpenFHE. I think it's from the OpenFHE devs, but that's a pretty cool paper that we should figure out how to do something with CPKS with LUTs. That would be a really cool research project. We had a rotation. Oh yeah, so I added eval fast rotation to the OpenFHE side of the API. So now it will identify common rotations and do the hoisting API. I haven't done the same thing for Latigo, so this is open for anyone who wants to try that. There is the question of double hoisting, which I forget exactly what the double part of it is. The first part is rotation hoisting, like eval fast rotation, and the other thing has something to do with the baby step, giant step details of the nature protected product. So there's an issue there with details there. Yeah, okay, this was the issue about OpenMP, figure out how to actually include OpenMP in the HEIR Pi wheel. I think it would be very sad if we had to disable OpenMP, at least because our only backend in HEIR Pi is OpenFHE, and it kind of needs OpenMP fast. So that will, yeah, that's, yeah, okay, anyway. Size mismatch on tensor extract. Oh, this was a new user filed this bug saying they gave some like manual loop doing something that looked like a matrix multiplication, and they used like tensor extract to get the scalars out and then multiply the scalars and then insert them back in instead of using like a matmul primitive or whatever. It should compile, but it wasn't compiling. So I have a PR here with a reproducing failing test. I think it will just fix itself when the layout system is done and the old layout system is removed, because I was looking at it and it looked like the problem was multi-packed ciphertext not being handled properly, or like two-dimensional data arrays not being handled properly. Okay, another one. So in removing the old layout, I ended up removing support for the lineage reduce kernel, which was sort of like a simplified thing that only worked if your data was packed into a single ciphertext. Now that we're doing multi-support of ciphertext packing, there's like a lot more options for how to implement this kernel. And rather than figure them out and block myself on finishing the layout migration, I just said, okay, we'll remove it and then come back to it later. So if anyone wants to try and tackle a fun lineage kernel, there's the lineage reduce. I think there is a parent ticket from Alex on compiler error messages and debuggability. Okay, this was another thing around shift networks supporting shifts going like negative shifts as some of the options. And then this is an issue for convolutions. I think we're starting to talk about average pooling layers in a neural network. I think there's more topics about max pooling and min pooling and other kinds of pooling. But it seems like right now everyone just takes max pooling layers and replaces them with average pooling. And okay, maybe there's an interesting research question there. But so we're talking about supporting average pooling for now. Yeah, during the migration of the layout system, we have this application data field on LW ciphertext that is meant to support the debug system, so that if you have an LW ciphertext and you want to do the thing where you like decrypt at each step and look at the decrypted stuff, this field was supposed to help you figure out how to unpack the result of decrypting it to something that the human could read. Now that we have the new layout system, this field actually, the best you can do is give it the basically give it the packed data, like so it would just decrypt and then print out like the clear text packed data in slot-wise form, and that's like not quite good enough. So this issue is to figure out like, okay, is there something we can do better where we can like keep the like layout information or the packing information on that field, so we can like properly unpack and get it back to like the regular user data. Okay, so that's it for notable new issues. Now we open the floor to discussion. The one thing I wanted to bring up is that the FHE.org talk next year, the submission for the talk is due, I think, November 1st. So this is the last meeting before we submit something, and I am opening the floor for options. My guess was that we should focus on the ML framework support for this talk, and then say like, okay, look at all of the new layout system, look at the Torch front end, look at we can run, and then we'll showcase whatever is like the hottest new model that we've implemented by the time that comes around. Right now it's just MNIST, but we promise we'll get more. But yeah, so I don't know if anyone has any other topics they'd like to throw in that I will include in there. If they're fine with me doing another like, what did we do since last year, right? Like my talk has every year been like, here's what we did since last year, kind of community update. They seem to be happy with those. I don't know if that will change, but focusing on ML support makes it seem a little bit more novel and like, look, here's something new to tell you about versus just like a laundry list of all the stuff we've done. So that was my idea there. But otherwise, I don't know who has topics to discuss.
Is it possible for anyone else who's participating and working on HEIR, we could have potentially more than one talk? Like, I really like the idea of like, I'm just putting this out there for people who have been working in this space and collaborating with the team. I really want that main ML focused talk, but there's a lot of other cool things going on. And if there's significant research for anybody here where you feel like this has enabled you and you want to cover that, I don't feel that it has to be looped in to that primary talk. So that's my only thought, so that people feel agency to be like, we're all building code here. This is a collaborative effort. There's a lot of impressive movement forward. So if you feel like you want to add another talk, we are very open. I think, Jeremy, you would align with me. We're really open to supporting anyone else who wants to give a talk. And we can frame these so that they're compatible.
Yeah, and they do posters too. So it's kind of and I don't think they accept talks of stuff that is published elsewhere as well. So
yeah. So if anybody's interested in that, but they need support or help or anything like that, please reach out to us.
No, but they do. Like last year, there was always like each year a couple of presentations about previous works, or like because I know like colleagues of mine have presented some papers like 3 or 4 times, and one of them was at FHE.org.
I definitely concur that doing an ML support talk would be cool. I think that we could showcase a couple demos and we could showcase how the layouts are optimized as well. So I think that would be interesting. But I'm also biased, so I've been working directly on that.
Yeah, I was actually gonna say, Oscar, maybe if you are interested, then you should be the one to give that talk. If you don't want to, I'm happy to do it, but I thought I would offer you as the like primary speaker for that one.
I will offer you a trade, Usenix for FHE.org. So I can do that FHE.org, and we can hope for the best.
I'm happy to take Usenix if
yeah,
we
exactly.
get it.
But the thing is, Usenix is only 3 minutes.
Oh, really?
Oh, really?
Yeah, they changed it this year.
No way.
Oh, it makes my job even easier.
Or I didn't should have mentioned that, and
easier, or you actually have to get a bigger punch in those 3 minutes. That can be hard too.
We got punch in here. It's okay.
Yeah, no, I know we have punch. It's fitting all the punch into that 3 minutes. It's like, yeah.
Oh, that's so interesting. 3 minutes. Wow. But yeah, no, I think it would be cool. I also hot off the press update got all the layout optimization for this MNIST Lynette style, like CNN style. So it is
Awesome.
exciting. And Jeremy, the layouts are indeed not Halevi shaped because of the input layout being different. So, but I haven't like analyzed them very carefully yet. So exciting. Oh, Lawrence is here. Hi, Lawrence.
Hi, how are you?
Good, good. Yeah, we're working our way. We're trying to catch up with you.
Awesome.
Yeah, we're hoping to get Bert Tiny before the summer. That'd be nice.
That's a tall task. I'm rooting for you guys. I am.
Well, we have
I've been working on
your work
GPUs
to lean on. So
yeah, I've been working on GPUs lately, and I've been using Google Cloud as well. So thanks for your guys' help.
yeah, one of the things
Ditto.
I'd like to do by the end of the year is add a GPU backend to HEIR, which I haven't had a chance to do yet.
Yeah, so I've been working with Fides Lib. They've been pretty responsive to me.
Do you like that one?
Yeah,
Good?
I like it.
Okay.
Yeah, so they're like API is a little different from OpenFHE, but I mean it took a little bit of learning for me to figure it out, but eventually I've got it. So where I'm at right now is I've gotten the matrix multiplications done in GPU, and I'm just kind of working on some of the nonlinear layers, and I think the Seda is one of the authors of Fides Lib, isn't right?
Yep.
Yeah. So I've been using your library. Thanks.
Yeah, the interface is not so user friendly. We're trying to improve it, so hope you didn't I hope you had a good time with it.
Yeah. I've been learning pretty quickly. So yeah. Yeah. Lately, I've been working on like a Chebyshev approximation. I think I was told by one of your co-authors that that you would eventually expose one, but I just kind of copied and pasted OpenFHE and then like turned it into Fides Lib. So yeah,
we do have another one. It does have some extra dependencies, but it's in HEIR already, and it's something that you can use immediately if you want to. So
Fides Lib actually had support for it too. So I did not know that HEIR has Chebyshev support. I thought your method was different, like the CF something.
Yeah, so that one, it produces a Chebyshev approximation. But so OpenFHE is just like a pure Chebyshev interpolation, right? Where they just say, okay, project onto the Chebyshev basis and don't do anything else. Ours will do a Chebyshev interpolation followed by solving a very sophisticated linear system that produces something that's more optimal, right? It's like it basically starts from a Chebyshev interpolation and then does some optimization to get closer to the true optimum. And there's I'm actually knee-deep in studying this stuff, like what everyone does. But the other option is this Remez algorithm. That one is like theoretically optimal, and then the claim that is made by people in the numerical analysis community is that the CF method is to machine precision, like to machine tolerance, as good as Remez, but like not theoretically optimal if you have unbounded precision. So they said, okay, CF method is like easier and simpler to implement, so just do that. But yeah, no, we have polynomial approximation, and it's pretty robust. So if you want to use it, you can. There's we separate the we have libutils polynomial, which represents the polynomials and does some basic operations on them, and then libutils approximation has the actual routines. And it depends on a linear algebra library called, what is it called?
May I ask you a question?
Yes.
So you said that the CF method is up to machine precision equivalent to RMS. But my question is, so we don't even have that much precision. Like after bootstrapping, we have, in the best case, something in the 20s bits of precision. So for those lower precisions, can a more efficient method be utilized?
That's a good question. I don't know. I've not heard of anyone in the numerical analysis community that has tried to come up with something. But like when you say more efficient, do you mean like more efficient in producing the approximation or producing a more efficient output circuit?
I believe both. Like I know that, for example, you had an open issue for dropping the smallest coefficients, something like that. Like for some parts, we don't have to compute some stuff like that would be included in the evaluation of it. But even in the generation part, like the generation of coefficients, yeah.
Yeah, well, I mean the generation of coefficients is very fast already in the CF method. So like I think probably it would not make a huge difference in computing the actual polynomial, but then in deciding how to evaluate it, there's probably something. Yeah, I haven't heard of anybody who's done something like that, where they said, oh, we know we only have 10 bits of precision or 16 bits of precision, so let's like try to optimize something with the generated circuit. I mean, it sounds like a very FHE specific thing.
Yeah.
Yeah. So that's a good research question, though. Yeah, okay, the two dependencies, one is called pocket FFT. So there's like a FFT routine used in the evaluation of the CF method, and then the other one is eigen, which is just like a general linear solver library. And we had that already in there for our tools, which uses this. Any other topics? Okay. I'm happy to make a short meeting. We don't need to fill the hour. But yeah, I mean, I guess the last thing I'll say is that like once I'm done with this layout stuff, I plan to do a lot of writing. So I want to go through and do like a documentation refresh on like the main website, as well as like the pipeline descriptions. Like our pipelines page is missing like half of our pipelines and has a bunch that don't exist anymore because it was all manual. And then I want to write like a design doc for the layout system, and then do a little bit of blogging for like a more human focused version of this, less into reference text. So like I'm expecting I'll probably spend 2 weeks this month of just like writing. And some of that will probably end up, going towards the paper and the talk and stuff because it's gonna, yeah. So yeah, look forward to that if you've been lost by all of the various things that have been going on in the code base. There will be more for it coming. Okay.
Yeah, I also feel like it's a good opportunity to write the docs about how to, like, from a dev perspective too, on how to use the kernel framework, like the arithmetic data framework, and then also how to use the layout system. So I think that now there's like, I'm fairly confident that it works so nicely. Like even with the thing yesterday, I was working on more extract, slice, collapse, shape op support, and it was like 5 lines of code.
Yeah.
That I did at like 5 p.m. So like my brain is already off. So it wasn't too bad.
Yeah. So yeah, I'll be doing lots of writing. And then I think we'll also do some writing to like show off the ML front ends as well. Like give some examples that people can run to like do MNIST and that sort of thing. So yeah.
Yeah, I think like I need to explore a little bit more about stress testing more, because I think it's like when you take 1 or 2 examples from like Torch MLAR or like other MLAR frameworks, like I have no idea whether that is all, and there's probably lots more little stuff to work on. Like even different ways of expressing a ReLU computation, like using a select statement versus max statements, all that type of stuff.
Yeah. We definitely have a lot more to go to get like coverage of the ML front ends in a meaningful way. Okay. Cool. All right. Well, thanks everyone for coming.